In July 2025, astronomers suddenly observed an interstellar object heading straight into the solar system. It was not a comet, and it was not an asteroid. But even more surprising, debate broke out when the James Webb telescope suggested it carried a steady heat pulse from deep inside, beating every 4 hours like a heartbeat. The light was too strong, the signals too precise, the orbit too strange. If this is the first sign of alien technology, humanity may be facing the greatest shock in history. The real question is, what truth will we uncover, and could it overturn everything we believe about life beyond Earth? Three-Eye Atlas was not just another rock in space. It was the third confirmed interstellar object ever seen, after Oumuamua in 2017 and Borisov in 2019. Unlike asteroids or comets born in our solar system, an interstellar object comes from far beyond, crossing the gulf between stars before we ever notice it. That alone made it rare, but the details quickly made it terrifying. Astronomers expected a cold chunk of ice and dust drifting at high speed, but the first readings from James Webb told a very different story. Buried deep inside Three-Eye Atlas, they found a steady thermal pulse repeating every 4 hours, almost like a heartbeat. The signal did not rise and fall with sunlight, and it did not match the object's rotation, which ruled out surface reflections or spinning tricks. It was coming from the core, consistent, mechanical, and impossible to explain with natural models. When Webb scientists shared the raw plots, the data looked simple but chilling, heat swelling and fading in perfect rhythm, as if something alive or engineered was beating in the darkness. The mystery deepened when radio astronomers joined the hunt. At the same time, the Allen Telescope Array turned its antennas toward Three-Eye Atlas and captured a faint radio signal. It was narrow, sharp, and matched the same 4-hour cycle as the thermal pulse. Background noise from the cosmos usually comes in random bursts, but this one cut cleanly against the static. Even stranger, the frequency drifted in sync with changes in the solar wind, as though the object was not only producing the signal but also reacting to its environment. That detail made many astronomers pause. Natural comets do not adjust to solar weather, but technology might. Independent observatories in South Africa and Europe checked their own logs and confirmed the pattern. The repetition was precise, the alignment uncanny, and the chance of coincidence was almost zero. To those who saw the numbers, the object no longer looked like a frozen ball of ice and dust. It looked more like a sensing system, an instrument designed to measure, perhaps even to watch. For the scientific community, this was more than a curiosity. It was a direct challenge to the assumption that all interstellar visitors are lifeless debris. Oumuamua had puzzled experts with its strange acceleration, but it had never produced a repeating signal. 2I Borisov had acted like a normal comet, offering no surprises. Three-Eye Atlas was different. Its pulse and radio echo suggested order, and order is the signature of design. Not everyone agreed on the meaning. Some called it an artifact of instruments, others spoke of exotic minerals or radioactive decay cycles. Yet each explanation fell apart when compared with the precise timing. Nature is messy. This was clean, deliberate, and regular, like the tick of a clock. The longer the data was studied, the clearer the mystery became. If the heartbeat was real, it meant that something inside Three-Eye Atlas was generating energy with exact control. That would put it closer to a machine than a comet. And if it was a machine, then the next question was far more unsettling. Who built it, and why was it here? Could an object traveling across interstellar space really be an artificial probe, quietly broadcasting into the void? Or are we misreading the first clear signal from a natural process that no one has ever seen before? One thing was certain: the discovery had turned 3I Atlas into more than just a strange rock. It had become a puzzle with stakes as high as the idea of life beyond Earth. And that raised the next mystery. If the heartbeat was only the beginning, what other secrets would this interstellar visitor reveal? In July 2025, a small survey project in Hawaii called the Asteroid Terrestrial Impact Last Alert System, or ATLAS, spotted something racing across the night sky. At first, it looked like a star drifting off course, but calculations quickly showed it was moving far too fast to belong to our solar system. The discovery was logged under the code 3I Atlas, marking it as the third confirmed interstellar object in history. The I stood for interstellar, and the name Atlas honored the system that first detected it. From the very start, this visitor was different. Its speed was clocked at more than 130,000 miles per hour, faster than any ordinary comet that astronomers had tracked before. Most comets crawl along predictable orbits shaped by the pull of the sun, but 3I Atlas cut through space like a bullet, following a trajectory that made it clear it came from the deep between stars. When the orbital path was plotted, it was obvious this was not a local object. It was a stranger passing through, and its approach toward the inner solar system sparked both excitement and fear. For scientists, spotting such a body is like catching lightning in a bottle. Oumuamua had flashed past in 2017 and left more questions than answers, while 2I Borisov had looked almost normal by comparison. Now, with 3I Atlas, researchers had a rare chance to watch another outsider cross the planetary neighborhood. Telescopes worldwide swung toward the coordinates, from mountaintops in Chile to desert arrays in New Mexico. Every observatory wanted a piece of the data. They were not only measuring speed and distance, but also brightness, rotation, and any signs of a comet tail. Each parameter could help reveal what kind of object this really was. Early reports noted the steady glow and unusual motion, but the larger context made it even stranger. Statistically, the odds of catching 3 interstellar objects in less than a decade were tiny, yet here it was. That raised a disturbing question. Were we simply getting better at spotting them, or was something about our region of space drawing them in? For the general public, the news carried a more emotional weight. Headlines framed it as a cosmic visitor arriving uninvited, and social media filled with speculation about hidden dangers or alien machines. The idea that an object from another star system was slicing through our skies captured imaginations in a way raw numbers never could. Scientists urged caution, reminding people that interstellar did not automatically mean intelligent, but the whispers had already begun. A body moving that fast, from that far away, could easily fuel myths as much as research. And as more instruments turned their gaze toward 3I Atlas, the first signs began to show that this was not just another harmless traveler. The question was clear. If its arrival broke the rules of normal comets and asteroids, what would we find when we looked closer? Before scientists could understand 3I Atlas, they looked back at the 2 interstellar objects that had come before it. The first was discovered in 2017 and was named Oumuamua, which means scout in Hawaiian. It was long, thin, and strange, with many comparing its shape to a cigar or even a flat pancake. What shocked astronomers most was not the shape itself, but the way it moved. After it passed the sun, it accelerated slightly, drifting off the path predicted by gravity alone. Comets can do this when gases escape and push them forward, but Oumuamua showed no tail, no dust, and no clear signs of outgassing. The acceleration was real, but the usual explanation was missing. Some scientists argued it could be a fragment of hydrogen ice, while others claimed it might be a sliver of rock that reflected sunlight in an unusual way. Harvard astronomer Avi Loeb made headlines when he suggested something bolder, that it could have been an alien probe using solar radiation as a sail. His claim was controversial, but it planted a seed. The idea that interstellar visitors might not all be natural began to grow. Then, in 2019, the second object appeared, named 2I/Borisov after the amateur astronomer who first spotted it. Unlike Oumuamua, Borisov behaved almost exactly like a normal comet. It had a clear tail, jets of gas, and a bright coma surrounding its icy core. Spectral analysis showed familiar chemicals like water and carbon dioxide, the same ingredients found in many comets that circle our sun. For researchers, Borisov proved that not every interstellar body is mysterious. Some are simply frozen travelers from other star systems, moving on long, lonely journeys before vanishing again into the dark. That should have calmed the debate, but instead it deepened it. If Oumuamua was bizarre and Borisov was ordinary, then the range of possibilities was clearly wider than anyone had guessed. So when 3I Atlas appeared in 2025, expectations were mixed. Some believed it would be another Borisov, a simple comet from afar, while others hoped for another Oumuamua, a chance to confront the unexplained. What no one expected was that it would combine elements of both and then add even stranger features on top. The steady light, the pulse, and the signals were not just unusual, they were unique. They pushed the mystery far beyond what the first two objects had offered. If Oumuamua was the warning shot and Borisov was the control sample, then 3I Atlas had become the real test. The question now was simple but unsettling. What kind of discovery waits when the rules of the past no longer apply? When astronomers first measured the brightness of 3I Atlas, the numbers did not make sense. Its glow was nearly 3 times stronger than expected for an object of its size and distance, and no model of a normal comet could explain it. The light was steady, smooth, and unwavering, while ordinary comets usually flicker as they tumble, venting gas in uneven bursts. This one did not flicker at all. High-resolution images revealed something even stranger. Instead of showing the classic streaming tail, 3I Atlas was wrapped in a teardrop-shaped cocoon of light. It looked more like a shell holding the object tight than a plume of dust spreading behind it. To observers, the image was unsettling. It was as if the object carried its own envelope, a glowing skin that defied normal comet rules. Even more unusual was the timing of the activity. Most comets only begin to shine when they move close to the sun, as heat turns frozen ice into vapor. But 3I Atlas lit up far earlier, while it was still beyond the orbit of Jupiter where sunlight is weak. That meant something other than solar heating was driving the brightness. Some teams suggested hidden stores of carbon dioxide or other exotic ice that could sublimate at lower temperatures. Others speculated about radioactive decay inside the core, releasing energy from within. But neither idea matched the data. The intensity was too high and the profile too consistent. If it was gas venting, the glow should have shifted or changed direction, yet the cocoon held firm. No known process in nature could account for such behavior. To the public, the story of a comet that glowed on its own was enough to spark headlines. Was it alive? Was it artificial? Or was it something in between? News outlets compared it to a lantern in the dark, carrying its own source of light across the sky. Scientists tried to calm the discussion, pointing out that many mysteries can be explained with patience and better data. But deep down, even seasoned researchers admitted that this was different. They were watching an object shine without cause, a cosmic lamp that refused to fade. The unanswered question only grew louder with each observation. What force could keep 3I Atlas glowing so brightly, so early, and so steadily? And if light was the first clue, what would happen when its energy suddenly changed? In mid-August 2025, every telescope watching 3I Atlas saw something extraordinary. Without warning, the object brightened by nearly 40% in less than an hour. For astronomers, such a sharp increase was unheard of. Comets sometimes flare when pockets of ice erupt, but those outbursts are chaotic and short-lived. This was different. The glow rose fast, then leveled off, and stayed fixed at a new higher baseline as if a switch had been turned on. Data from TESS in Earth orbit confirmed the same surge, while ground-based observatories across Europe and Asia measured identical spikes. Hubble recorded the moment with clarity, showing no cloud of dust or gas escaping to explain the light. The object had simply powered up. The shockwave in the scientific community was immediate. If this was a comet, then it was the first comet in history to act like a machine. Soon after the burst, another anomaly appeared. Orbital calculations no longer matched the original path predicted months before. Instead of drifting passively, 3I Atlas shifted slightly closer to the plane of the solar system. It was a small but clear deflection, enough to prove that its movement was no longer following the rules of gravity alone. Teams checked for measurement errors, but independent observatories found the same deviation. The burst of energy and the change in trajectory were locked together in the logs, happening within hours of each other. That link forced a question few dared to speak. Had the object just performed a maneuver? Scientists who studied comet dynamics knew the signs of outgassing, yet nothing in the data matched those patterns. There were no plumes, no jets, and no evidence of thrust from vented material. This was not a random push, but something precise, as if the object had corrected its own course. In astronomy circles, a new phrase began to circulate: maneuver signature. It was a cautious way of saying that 3I Atlas behaved less like a drifting rock and more like a guided craft. For the public, the story exploded. News outlets called it the comet that turned and compared it to a spacecraft firing engines in deep space. Online forums filled with speculation about alien probes, secret missions, and even warnings of first contact. Scientists tried to slow the rush, but the evidence was hard to ignore. A natural body does not brighten like a bulb and then bend its orbit in sync. The combination of the two events was too clean to dismiss. If the burst was real power and the turn was real control, then the implications reached far beyond astronomy. And that left one haunting question hanging over the next round of observations. If it could change course once, what might it do next? After the burst and the sudden shift in orbit, scientists turned to the James Webb Space Telescope for deeper answers. Webb's instruments are designed to read the spectrum of light, breaking it into fingerprints that reveal what elements are present. When the raw spectra from 3I Atlas came in, researchers expected to see familiar markers of ice, dust, or carbon compounds. Instead, what they found shocked the community. The data carried signatures of rare earth metals, the same materials used in advanced electronics and aerospace technology on Earth. These elements are not common in natural comets, and their presence in such concentration raised serious doubts. Even more surprising were lines in the spectrum that matched no known catalog. Some peaks aligned with theoretical quantum materials, substances that until now existed only in research papers and laboratory models. They were predicted to have unusual properties, like conducting energy without loss or reflecting light in precise ways, but they had never been observed in space. Yet here they were, showing up in the light from an interstellar visitor. The combination of rare alloys and exotic structures forced many to rethink their assumptions. Nature could create odd mixtures, but this looked organized, almost engineered. To many observers, the pattern resembled the output of manufactured surfaces rather than random cosmic chemistry. A comet or asteroid should show messy blends of rock and ice, but 3I Atlas displayed sharp, deliberate signals. That difference could not be ignored. Some scientists argued for patience, suggesting unknown minerals or unusual crystal growth might mimic those results. Others noted that data from multiple observatories confirmed the same lines, ruling out instrument error. The debate was fierce, but the fact remained: the spectra looked artificial. For the public, the revelation spread quickly. Headlines claimed Webb had found alien metals, and social media amplified the idea that the object was not a comet at all. The comparison was often made to finding steel or titanium inside a rock from space, something that would instantly suggest design. Even cautious researchers admitted that the signals pointed to something extraordinary. If the spectrum was correct, then 3I Atlas was more than a visitor. It was a puzzle piece from a technology far beyond anything humanity had built. The discovery shifted the tone of the investigation. What had started as a study of a mysterious comet was now turning into a search for evidence of engineering on a cosmic scale. And as questions grew louder, one decision pushed the mystery to its breaking point. Should humanity try to speak to it? When the strange spectra and unusual movements of 3I Atlas became impossible to dismiss, a group of international scientists decided to take the next step. Instead of only watching, they would try to communicate. The method was simple in theory, but daring in practice. Send a signal coded with universal patterns that any intelligent system should recognize. They chose prime numbers, the periodic table, and a few constants of physics, believing that mathematics and science were a language that crossed all boundaries. The transmission was sent through powerful radio arrays aimed directly at the path of 3I Atlas. After that, the world waited. Days passed with silence, and many assumed nothing would happen. But on the third day, a reply came back. It was faint, distorted, and wrapped in static, yet within the noise was a clear structure. The pattern mirrored the prime sequence, though bent and shifted as if it had traveled through a filter. It was not a random echo. It carried intent. The discovery shook the team to its core. Some argued it was simply a reflection of Earth's own broadcast bouncing in unexpected ways, but the timing and shape ruled that out. Others feared the data could be misunderstood, but the repeating pattern left little doubt that it was a crafted response. Within hours, NASA and ESA restricted access to the raw signals. The public only learned fragments, while the full analysis moved behind classified channels. Official spokespeople gave vague statements describing the event as under review, but inside the research community, the mood had shifted from curiosity to unease. Why would an interstellar object send back a distorted version of what it had received? Was it proof of a receiver acknowledging the call, or a technology reflecting information in ways humans barely understood? For the scientists who had worked in secret, it felt like standing at the edge of contact, yet also the edge of danger. The idea that something out there had noticed Earth was no longer just speculation. It was now supported by data. The reaction forced many to ask a question that had no easy answer. If 3I Atlas could hear us, what else might it decide to do? The final step for scientists was to test every natural explanation they could imagine. They began with outgassing, the process where ice buried inside a comet turns to gas and pushes the body forward. This idea had worked before, but it failed here because 3I Atlas showed no tail and no signs of escaping gas. The heat signature was steady and rhythmic, something no random jets of vapor could create. Next came the theory of radioactive heating. Maybe the object carried unstable elements that released energy from inside, giving it a false heartbeat. Yet the thermal data did not match radioactive decay, and the repeating 4-hour cycle had no parallel in geology or chemistry. Others suggested dust scattering. Perhaps the unusual brightness came from a shell of fine particles reflecting sunlight in strange ways. But telescopes across the world confirmed that the glow stayed stable and smooth, not shifting like dust clouds normally do. Every attempt ended the same way, with pieces of the puzzle left unsolved. By late August, the International Astronomical Union held a private debate where experts from multiple countries compared results. The list of failed models grew longer. No comet behavior, no asteroid record, no known physics could explain the heartbeat, the spectral alloys, or the precise radio patterns. One astronomer admitted, "We are in uncharted territory." The word spread quietly, and even within classified reports, the tone had changed. The mystery was no longer about finding the right box to fit the object in. It was about accepting that maybe no existing box would work. Some experts suggested we were facing a new class of cosmic phenomenon, something nature had hidden until now. Others whispered that the object might be a construct, a machine built by intelligence, drifting through the stars long before humans could even dream of flight. In either case, the conclusion was the same. 3I Atlas had pushed science to its limits. It had forced astronomers to admit that not everything in the sky can be explained by the rules written so far. For the public, only fragments of this debate leaked out, leaving people with rumors, half-truths, and endless questions. If the world's brightest minds could not solve it, what did that mean for the rest of us? And more importantly, if 3I Atlas was not natural, then who or what was responsible for sending it across the galaxy? 3I Atlas was not just another rock from space. It carried signals, heat, and movements that broke every rule we thought we knew. No natural model could explain it fully, and that leaves us with a question we cannot ignore. What exactly is it that we are about to witness for the last time? Could it be carrying alien technology that goes beyond the limits of human understanding? Whatever the answer may be, one truth remains. The universe is far stranger than we imagine, and every discovery carries meaning.